I'm Ken Wright, and I'm a professor of integrated physiology here at the University of Colorado Boulder. I'm also the director of the Sleep and Chronobiology Laboratory. In this video abstract, my students and I will present findings from a research study aimed at understanding the influence of natural versus electrical lighting on our internal clock.
Electric light is one of the most important human inventions, and its widespread use has transformed our home, work, and social environments, resulting in humans spending more time indoors during the day and permitting us to work and play far into the night. However, sleep and other daily rhythms in our physiology and our behavior have evolved in the natural light-dark cycle, and electrical lighting is thought to have disrupted these rhythms.
Light affects our physiology in many ways, vision being the most obvious. However, beyond conscious vision, one of the important effects of light is to provide a time cue that syncs our internal clock to the external environment.
The internal clock is located in the suprachiasmatic nucleus of the hypothalamus. Photoreceptors in the eye send light information to this area. Once this information is processed, signals are then sent to the rest of the body to indicate time of day.
We can tell the timing of our internal clock by measuring levels of a hormone called melatonin. Melatonin levels are low during the daytime. They tend to rise about 2 hours before we go to sleep at night. They're high throughout the night, and then they return to low daytime levels again shortly after we awaken in the morning. The internal clock is important as it coordinates much of our physiology and behavior, including the time of day when we eat, when we perform at our best, as well as when we sleep.
Night owls actually have a later timing of their internal clock, whereas early birds have an earlier timing of their internal clock. But this has only been shown after exposure to modern electrical light dark cycles in the constructed environment.
Humans are unique as a species in that with the flip of a switch, we can instantly change our external lighting environment, regardless of time of day. While this is a critical component of our modern world, it raises an important question. How much has this modern light exposure altered the timing of our internal clock?
We answered this question by taking people camping.
The participants wore special research watches, like this one, that allowed us to measure the timing and duration of their sleep. The watches have a light sensor that allows us to measure when they're exposed to light as well as the intensity of that light. They wore these watches continuously as they carried out their normal daily activities, going to school, going to work, during social activities, and while sleeping at home. After 1 week, we brought the participants to the laboratory for a 24-hour visit so that we could determine the timing of their internal clock by measuring levels of the hormone melatonin. To do this, we collected saliva samples every hour. We then took everyone camping for a week in the Rocky Mountains of Colorado. They slept in tents and were exposed to only natural sunlight and the light from campfires. After camping, we drove participants directly back to the laboratory so that we could reassess the timing of their internal clock.
When camping, people were exposed to light levels that were 400 times brighter than during their normal daily activities. This increase in exposure to sunlight led to an earlier timing of the internal clock, as shown by the change in melatonin levels. This shift could make us more alert in the morning, since our clock is no longer promoting sleepiness after we wake up.
We actually found that night owls did still have a later timing of their internal clock when exposed to the modern electrical light dark cycles in the constructed environment. But after only 1 week in the natural light dark cycle, these individuals' clocks became more similar to that of early birds.
In conclusion, we showed that the reduced exposure to natural lighting during the daytime and an increase in exposure to electrical lighting, especially at night, has led to a change in the timing of our internal clock, and this has resulted in a major change in the timing of our sleep and our wakefulness.
In lieu of camping, we can make changes in our daily lives to increase our exposure to natural sunlight and decrease our exposure to electrical light. For example, starting the day with a morning walk or run, raising the shades in the house, and taking a break at work to go outside. On the flip side, lowering the lights at night before we go to bed, and dimming our electronic devices. Increased exposure to sunlight may help reduce the physiological, cognitive, and health consequences associated with disruption of our internal clock.